All right, we are in start of chapter 10. Uh, chapter 10 deals with dealing with geometric shapes, talking about measurements, and also we're going to get into some components of area and volume. Section 10.1, we're going to talk about angles and triangles. Um, One of the things that we're going to take a look at, something that we were exposed to earlier in the semester, is being able to use protractor. This is the protractor right here, and this is allowing us to figure out angle measurements. One of the more accurate ways to measure it by hand. Um, there are uh, three different kinds of angles, well, it's actually four different kinds, but we're going to take a look at three of them here today. The first three are acute angles, right angles, and obtuse angles. So when we're going to deal with acute angles, by definition, acute angles are any angle that is less than 90 degrees. So the example that we had here on the first page is kind of an example of an acute angle. If you look at it, it looks like it's about 4 degrees on the protractor. So 40 degrees is less than 90, so that would be considered an acute angle. A right angle is an angle that is exactly 90 degrees. So when we were talking about right angles using Pythagorean theorem, stuff like that, those are all, like right angle triangles, so it had a right angle. Um, and then obtuse angle is any angle greater than 90 degrees, but it's less than 180. So anything that's 91 degrees and 79 degrees, anything in that range would be considered an obtuse angle. Straight angles, here, just kind of like right angles, it has an exact number. It says this angle is exactly 180 degrees, which means it's a straight line. So it looks something kind of like this. So anytime you have a straight line, whether it's horizontal, vertical, diagonal, whatever which way it is, that is a line that is exactly 180 degrees. So from the definitions above, we're going to try to predict what the following vocabulary words might mean. So we have acute triangles, we have right triangles, and we have obtuse triangles. Okay, so from acute angles, we said acute angles were any angle that was less than 90 degrees. So that means that an acute triangle is going to be a triangle. I'm just going to put the symbol of triangle, that all three angles are less than 90. So each one of those triangles would be less than 90 degrees. A right triangle means one of the angles is a right angle, which means it's 90. And then obtuse triangle, this means that only one angle is obtuse. Okay? And if you look on over here, these are some classifications of triangles represented by their sides. So if you have a equilateral triangle, that means that the triangle sides are all equal. So if you look at this one here, all of these sides would be equal. This would be an example of an equilateral triangle. An isosceles triangle are triangles with two sides that are equal. So in this case here, this would be an example of a equilateral triangle because you'd have two equal sides. The one on the bottom, in fact, is not equal to the other two. And then scalene triangle means that's a triangle with no equal sides. So this one right here, we're going to say that's an example of a scalene triangle. So like the distance here is different than the distance here, which is different from the distance here. Okay. So just to kind of reiterate what we talked about, acute triangles are triangles that have three acute sides. Um, this would be, I'm sorry, obtuse. Obtuse triangles are triangles with one obtuse angle, and right angles are triangles that have one right angle. And then this is just what we talked about in the previous page. All right, so they're asking us to classifying triangles. All right, one of the rules that we talk about when we're dealing with any type of triangle, all of the interior angles in a triangle have a sum of 180 degrees. So I have a triangle here where they're giving me two of the measurements. I have 61 degrees here and I have 45 degrees right here. They're asking us to find the third angle. Well, we can do that by taking 61, adding it to 45, adding it to x, and we know that the sum of all three of those is going to equal 180. So if I take 61, add to 45, I get 106 plus x equals 180. To solve for x, I'm just going to subtract 106 to both sides, which then gives me 180 minus 106. So that means that x is going to be 74 degrees. And they're asking you to classify it by its angles. All three angles are less than 90, so this would be an example of an acute triangle. Over here, they're asking you, it says, can the angles in the triangle have the measurement given? And they're asking you to explain. Anytime they want you to explain, which basically they're asking you is, do all three angles add up to 180 degrees? So if I took 67 and added it to 108 and I added it to 15, I would get 190 degrees. So I would say no, this could not, those measurements would not make up a triangle because their sum is 190. It needs to be 180. So I go over here, I got 163 plus 10.7 plus 6.3. It gives me 180 degrees. I could say yes. This one adds up, the sums add up to 180 degrees. These three angles do in fact make it a triangle. I go over here, I have 22 and 2/3 plus 57 and 1/3 plus 100. I get the same thing, 180 degrees. I can say yes because it adds up to 180 degrees. It satisfies that all interior angles must have a sum of 180 degrees. You're going to be asked to do some problems where you have a variable in several spots, and in some instances they're asking you to just find the variable for x. Sometimes they're asking you to find all three angles of the triangle. So we'll do both. So in this case here, I have x degrees, I got x plus 13 degrees, and I got x plus 38 degrees. All right, from the previous pages, we know that when we add up all of these sides, we know that we are going to get a sum of 180 degrees. So then from here, what we get to do is this. We get to combine like terms. I have like terms with the three values of x. So x plus x plus x gives me 3x. Plus I have like terms of 38 plus 13, which gives me 51. So now I have 3x plus 51 equals 180. Solve for x, I subtract 51 to both sides. I get 3x equals 129. And then I divide everything by 3, which means that x equals 43. So x equals 43 here. If I were to plug it back into the original angles, I would get 43 here. I would get 43 plus 38, which gives me 81 degrees here. Put the degree sign here. And then finally 43 plus 13 gives me 56 degrees here. And if you were to add those three angles up, you would get 180 degrees. Finally, we have a story problem here. It says the ratio of the side lengths of a triangle is 3 to 5 to 7. Excuse me. The perimeter of the triangle is 105 feet. Find the side lengths, then classify the triangle by its side length. Okay. So we know that perimeter is the sum of all of the sides of this triangle. So they don't tell us the exact sides, but they tell us the ratio. So they tell us this is 3, this is 5, and this is 7. We don't know anything else about that, but we do know that it would be multiplied by the same value. So I'm just going to attach an x to each one of these side lengths. We also know that 3x plus 5x plus 7x in this situation is going to equal 105, because that's what it told us, that the perimeter of the triangle is going to be 105 feet. So now we get to combine the like terms. We have 3x plus 5x, excuse me, plus 7x gives us 15x. So 15x equals 105. And all we have to do is divide it by 15. So 105 divided by 15 gives me x equals 7. So they're asking to find the side lengths. So all you're going to do is you're going to multiply 7 by 3, 5, and 7, which means I'm going to have side lengths of 21 feet. I'm going to have a side length of 35 feet. And I'm going to have a side length of 49 feet. And if I were to classify this, all of them are different measurements. So this would be an example of a scalene triangle. All right, that is being able to use angles and triangles and being able to solve them for different triangle shapes and angles. Hope this helps. Until next time.